So we're just going to rationalize a denominator because there's a rule that says you're not allowed to have something with a square root under a fraction. So the first type of problem is when you have just a single radical in the denominator. So this would be like type 1. What you do with the single radical is we just use the properties of radicals to get rid of it. What the square root of 2 is saying is this is the number that you would multiply by itself to get 2. So what I'm going to do on the bottom here is I'm going to multiply by the square root of 2. Now if I do something to the bottom of a fraction, I need to do it to the top of a fraction. Now this is legal because this number right here would just simplify to the number 1, and I know that multiplying anything by 1 doesn't change the value, so I'm writing an equivalent number. So on top, 5 times the square root of 2. Now on the bottom, by definition, the square root of 2 times the square root of 2 is the square root of 4. In other words, it's just 2. So we get 5 root 2 over 2. On this example, we have just a single root in the denominator. So to get rid of it, I'm going to multiply it by itself on the top and the bottom. So our new numerator, we have negative 9 times the square root of 10. And those cannot be combined in any other manner. And on the bottom, we have the square root of 10 by the square root of 10, which is by definition 10. Simplifying this, again, we notice we only have a single radical in the denominator, so we're going to multiply the top and the bottom by that radical. Now here we see a slightly different problem just because there's another radical on top. So two radicals can combine to be a single radical with multiplication. So root 3 and root 5 is root 15. And then we know from before that root 5 times root 5 just undoes to be 5. Here we have a single radical on the bottom, so to simplify, we're going to multiply the numerator and the denominator by that radical. So on top, one radical times another radical can equal a single radical, and 3 times 12 is 36. On the bottom, we get root 12 times root 12 undoes each other to be 12. Now here we're going to simplify. We know the square root of 36 is 6, and 6 over 12 is 1/2. Here, just our general case, doesn't matter what is on the bottom, we're going to multiply by that square root to get rid of it. So we know that the square root times itself undoes each other, so our new denominator is x, and on top we have 5 times the square root of x. To undo a single radical in the denominator, we are going to multiply by that radical, the top and the bottom. So our new numerator, 2 times 5 is 10, x times x is x squared, and on the bottom the radicals undo each other. Now here we're going to simplify the top just a little bit because there's a perfect square there. So the square root of x squared is just x, root 10 over 5x. So the x over the x would reduce, so we'd get root 10 over 5. Now here we have to notice that we have more than just a single radical, so this is something like type 2. If I were to just multiply the top and the bottom by that single radical, it doesn't accomplish my goal. On top I get root 2, but on the bottom, after I distribute, I get 3 root 2 plus 2. It changed the way it looked, but it didn't get rid of that denominator on the bottom, so it's actually not going to help us at all. So in problem type number 2, what we have to do is actually multiply by the conjugate. And the conjugate, if you have something, the conjugate is where you change the sign in between it. So the conjugate of 3 plus root x is 3 minus root x. The conjugate of root 2 minus 3 is root 2 plus 3. Again, just changing the sign in between them. So to solve this problem, what we're going to have to do is simply multiply by the conjugate. So the conjugate here is 3 minus root 2. So I do that to the top and the bottom. So our new numerator will distribute, just becomes a 3 root 2. Now our denominator, when we do our distributive property, 3 times 3 is 9. Then I get 3 times negative root 2, which is negative 3 root 2. Now on the inside, I get 3 times positive root 2, which is positive 3 root 2. And our final thing is positive root 2 times negative root 2. So that's a negative number, and root 2 times root 2 is just 2. And the good thing to realize here is that minus 3 root 2 and plus 3 root 2 cancel out. So on the bottom, we're just left with 7. So we've successfully rewritten this number without a radical on the bottom. Here what I notice is, again, we have more than just a single radical, so we're going to multiply the top and the bottom by the conjugate pair, and the only difference is we just change the sign in between them. So now on top we're going to distribute, so root 3 times root 2, a root and a root make a root, so that's root 6. Then root 3 times a positive 4 is just 4 root 3. In the denominator, root 2 times root 2 is a 2. Root 2 times positive 4 is positive 4 root 2. Then negative 4 times positive root 2 is a negative 4 root 2. And then negative 4 times positive 4 is a negative 16. So those will cancel. So on top we have root 6 plus 4 root 3. And on the bottom we have 2 minus 16, which is negative 14.